We're on example 9 of section 2.4 on circles in our topic of conics. Example 9, we're given a graph and we're to find the standard form for the equation of the circle. So to do that, we're going to find the center and the radius. All right, so we're given 2 points. This is the point 1.5, 3.5. I might write it a little bigger in case you can't see that. 5. And this is the point 1.5, negative 1.5. So we're given these 2 points on the circle. They're actually on either end of a diameter that goes through the center. So we know that this halfway between these 2 points should be our center, halfway between those. So what would that be? So the radius, if we knew that length and cut it in half, we would know the radius, right? So the length would be the difference between 3.5 and 1.5. So it's 3.5 minus the negative 1.5. Okay, that's that distance. That's the length, the difference between positive 3.5 and negative 1.5 in the y direction, the difference of the y's divided by 2. Well, that ends up being what? 5 over 2. So our radius is 5 over 2, or what's that, 2.5? They're using decimals, so I guess we can use decimals here. Now, what's the x-coordinate of our center? Well, to get to either one of these points on this diameter, we had to go out to 1.5. Both of the x-coordinates are 1.5, so the x-coordinate is equal to 1.5. It also would be on this vertical line, x is 1.5. What about the y-coordinate? Well, we know the y-coordinate would be, here it's 3.5, but to get to this point, but we want to subtract off the radius, and that would tell us from the y-axis, x-axis here, how high up we go. So the question is, what's that length there to get us to the center? That will be the y-coordinate, because this is our x-axis right here. So if we took this total amount, 3.5, and subtract the radius, which was 2.5, we get 1. So this is our center, 1.5, 1. That's the center. Come out 1.5, go up 1, you're here at the center. So we have our center now. So we know that if we have our center and we have our radius, we can write our equation in standard form, right? That's all we need. So for our equation in standard form, it's x minus h, which is 1.5 squared, plus y minus k, which is 1 squared, equals 2.5 squared, right? So this is x minus h squared plus y minus k squared equals, what's 2.5 squared? Let's see, what would that be? 6.25, I believe. Okay, so we took a graph and we came up with our equation in standard form. Let's look at example 10. It just says to find the center, the radius, and the x-intercepts and y-intercepts. So that's different. We haven't done that yet. Of course, the center would be what? The center is the point. Well, I don't want to put equals c. Usual notation, I'll just put c is 0, 0. We know that, okay? The radius is the square root of 16, or 4. And how do we find the intercepts? Well, to find the x-intercepts, let's let y equal 0. So we have x squared plus 0 squared equals 16. So x squared equals 16. And the square root of x squared equals plus or minus the square root of 16. So x equals plus or minus 4. And we'll let x equals 0 to find the y-intercepts. So 0 squared plus y squared equals 16. And don't we go through just the same analysis? The square root of y squared equals plus or minus the square root of 16. So y equals plus or minus 4. So the intercepts are 4, 0, negative 4, 0, 0, 4, and 0, negative 4, right? Centered at the origin. Okay, and finally, example 11, I believe that's our last one, we are to find the center and radius and intercepts given this equation. Now, it looks like it's in standard form, but it really isn't, is it? Because standard form doesn't have a factor out here in front like that. So what do we need to do first? Yes, we're going to divide everything by 2. Every term in this equation. So we get x plus 3 squared plus y minus 3 squared equals 25. So the center is what? Negative 3, 3, yes. The radius is the square root of 25, or 5. Okay, and find the center, radius, and intercepts. Okay, let's let y be 0 to find our x-intercepts. And I'm going to go to our standard form here. And so what do we have? We have x plus 3 squared plus 0 minus 3 squared equals 25. Okay, so this is going to be what? X squared plus 6x plus 9, foiling that out, plus negative 3 squared, 9 equals 25. So we have x squared plus 6x plus 18 equals 25. And subtract 25 from both sides, and we get what? X squared plus 6x minus 7 equals 0. Okay, and is that factorable? What? Positive 7 and negative 1. So x equals negative 7 and x equals 1. All right, so we found x-intercepts at negative 7, 0, and at 1, 0. What have we got so far? We've got our center at negative 3, positive 3. We've got an x-intercept at negative 7, an x-intercept at positive 1. Now let's look for the y-intercepts. I can do that over here. Let's let x equal 0. So we'll have 0 plus 3 squared. 0 minus 3 squared equals 25. Whoops. Wait a minute. Not 0 minus 3. We are solving for our x equals 0. We're solving for our y. There we go. So this will be 9 plus y squared minus 6y plus 9 equals 25, right? Y minus 3 times y minus 3. All right, so we have y squared minus 6y plus 18 equals 25. So y squared minus 6y minus 7 equals 0. Subtracting 25 from both sides. And does this factor? So what would we need? A negative 7 and a positive 1, right? So y equals positive 7, y equals negative 7, 0, 7, and 0, negative 1. Let's see if this is going to make sense. 0, 7, and 0, negative 1 for our y-intercepts. Okay, so if we go out 5 units, 1, 2, 3, 4, 5, and like the north, south, east, west directions, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 with our 4 intercepts and our 4 points. It looks like we've got a circle here. Let's see. Here, and then